imagine you're trying to drive a Ferrari at like 200 miles an hour, but your security team has installed speed bumps every 10 feet.
Yeah, that is pretty much the enterprise software experience right there.
Right, so you want to move fast, but security is just constantly slamming on the brakes. Well, welcome to the deep dive. Today we're looking at an enterprise architectural guide for GCP application development services. And our mission is to decode how Google Cloud actually attempts to fix this fundamental tension.
It really is the classic friction point. I mean, we've always treated security as a gatekeeper, but this guide challenges that entirely. It's about shifting security from a roadblock to like a paved road where the safest route is actually the fastest one.
Okay, let's unpack this, starting with the foundation of this ecosystem. We're talking about the Application Design Center, or ADC. And when reading through the source, ADC jumped out to me as basically being like bowling with the bumpers up.
That is a really good way to put it, yeah.
Because it gives you this visual drag-and-drop canvas, right? So developers can deploy complex architectures without needing to be absolute wizards in infrastructure as code.
Right, they aren't spending days scripting out every single networking rule by hand. But to understand why that matters, let's extend that bowling metaphor. These aren't just inert plastic bumpers.
Oh, right. They're active.
Exactly. The ADC canvas is wired directly to your company's security command center. So before the ball even leaves your hand, before any code is actually deployed, the system analyzes the trajectory. It checks your visual design against strict enterprise security policies.
Ah, so that's how it eliminates configuration drift right at the source. It stops that nightmare scenario where your live environment slowly stops matching your original code because people made unapproved manual tweaks.
Yeah, that is the exact mechanism. And what's fascinating here is the architectural rule it establishes for massive organizations.
Which is what exactly?
Well, if you're building a highly bespoke system, sure, you still drop down and write raw Terraform scripts. But for the vast majority of your engineering teams, you use ADC to build an internal developer platform. Teams just self-serve off-the-shelf, pre-approved blueprints that are secure by default.
Okay, I get that. So once those infrastructure bumpers are up, you have a safe, governed environment, but that just gets you an empty lot. How do teams actually build the user-facing app so quickly? The guide points heavily to Firebase, Firebase.
Firebase.
I mean, I always thought of that as a neat tool for a couple of startup founders building a mobile app in a garage. If I'm a massive, highly regulated bank, why on earth am I using Firebase instead of building my own custom microservices?
It's a completely fair assumption to challenge. But building custom microservices for absolutely everything is a massive drain on enterprise resources.
It takes forever, yeah.
Right. So if we connect this to the bigger picture, it all comes down to a strict decision matrix. Firebase is purpose-built to offload the plumbing for client-facing apps. Think mobile or web apps that desperately need offline state synchronization.
Meaning, if a user drives into a tunnel and loses cellular service, the app doesn't immediately crash. It just syncs their data back to the server the second they get a signal.
Exactly. And Firebase handles that incredibly complex data syncing out of the box, along with rapid user authentication. Now, conversely, if you're dealing with heavy microservice-to-microservice data crunching, you have to pivot.
Like migrating a 20-year-old legacy database.
Right. That is when developers must choose heavy-duty container orchestration tools like Cloud Run or GKE, paired with a traditional Cloud SQL database.
Okay, I'm tracking. You've got your infrastructure governed by ADC. Your user-facing plumbing is handled by Firebase. That really just leaves writing the unique business logic that actually makes your company money. And here's where it gets really interesting.
The AI piece.
Yes, AI is supercharging that exact step. The guide highlights Gemini Code Assist, which sits right inside your IDE, like your VS Code or IntelliJ. It claims to boost developer productivity by 30 to 40% by generating tests and explaining clunky legacy code.
But that claim immediately raises a massive red flag for enterprise governance, right? Everyone asks, are we feeding our top-secret proprietary algorithms into a public AI model?
Exactly. You do not want your company's core payment logic showing up in a stranger's AI prompt.
Definitely not. And the guide addresses this head-on through localized, tenant-isolated fine-tuning. Google Cloud provides enterprise controls that allow Gemini to learn your company's specific coding patterns.
By analyzing your private repositories, right?
Yes. But it does this inside a walled garden. Your source code never, ever leaks back out to train the public AI models. It is completely isolated.
So what does this all mean for you listening right now? Well, whether you're a platform engineer setting up the guardrails or a front-end developer trying to ship a new feature, This entire GCP stack is designed to remove friction.
Yeah, it shifts the cognitive load entirely. By letting machines handle the boilerplate infrastructure and the security validations, humans actually get to focus on solving real business problems.
It offloads all those tedious, non-functional requirements, but, it does leave you with a pretty wild thought. If Gemini Code Assist is already boosting productivity by 40% using these tightly governed enterprise templates, how long until the primary role of a software engineer shifts from writing original code to simply auditing AI-generated architecture? Something to chew on.